Assalamu alaikum class 9. Today we are going to continue exercise 1.5 question number 4. They are asking us about the two matrices A and B, and here are two proofs. Here are they saying in the first part A into adjoint of A is should be equal to adjoint of A into A, and it must be equal to determinant of A into identity matrix. Okay, so let's pick up the left hand side and start doing the proof. Left hand side, which is A into adjoint of A. What is the matrix A? 1, 2, 4, 6. And what is the adjoint of matrix A? Change the places of the diagonal entries and change the sign for other entries. Now multiply the both of the matrices. 1 into 6 is 6 minus 4 into 2 is 8. Then 1 into minus 2 plus 2, 4 6 are 24, plus minus 6 4 6 are again 24. Then 4 2s are 8 plus 6 1s are 6. That is equal to 6 minus 8 is minus 2. It's 0. It is 0, and minus 8 plus 6 is minus 2 again. Because when opposite sign appear, then we will do subtraction. 8 minus 6 is 2, and you are going to put the negative sign with it. So it is all done. Now we are going to do the adjoint of A into A. Adjoint of A is this: 6 minus 2 minus 4 and 1. This is the adjoint of A. And A is this: 1 2 4 6. Six into 1 is 6, minus plus minus 4 2s are 8. 6 2s are 12, minus plus minus 6 2s are again 12. Minus 4 plus 4, minus 4 2s are 8, plus 6 1s are 6. Six minus 8 is minus 2, 12 minus 12 0, minus 4 plus 4 0, and minus 8 plus 6 is minus 2. So this is the result of adjoint of A into A. Both of the matrices are same. Okay. Now determinant of A into identity matrix. What is the determinant of A? 6 into 1, 6 minus 4 2s are 8. Okay, so this is going to be the determinant, and identity matrix means 1 0 0 1. 6 minus 8 is minus 2. 6 minus 8 is equal to minus 2. I am going to multiply minus 2 with the all entries of identity matrix. So, dear students, you can see that this matrix is equal to this matrix as well as this matrix. Okay? So, it is proved that, hence proved that A into adjoint of A is equal to adjoint of A into A equals to determinant of A. Now part number 2. B into B inverse should be equal to identity, and that should be equal to this. Now the left hand side, B into B inverse. What is the B matrix? 3 minus 1, 2 minus 2. And B inverse. For B inverse, we are going to take adjoint, means changing the places of these two, and then changing the sign of these two. So we have done the adjoint of matrix B. Now we are going to divide it with the determinant of B. What would be the determinant of this matrix? Minus 3 2s are 6, minus 6, then put the negative sign of the formula, then minus 2, that would be plus 2, because minus into minus 2 is always equal to positive 2. Okay, this is done. Now minus 6 plus 2. What would be the answer of minus 6 plus 2? We are going to do the subtraction. 6 minus 2 is 4, and put the negative sign of the greater number. Because we are putting the negative sign all because it is appearing with the big number. Okay, the larger number. Okay, now multiplying minus 4. You can write it as minus 4 to minus 2 1 minus 2 3. Okay, now I'm going to put minus 1 by 4 outside and multiplying these two matrices, just for the convenience. Minus 3 2s are 6, minus minus plus 2 1s are 2, 3 1s are 3, minus plus minus, and 3 1s are 3 again. Plus minus minus, 2 2s are 4, then minus minus plus, 2 2s are 4, 2 1s are 2, minus plus minus, 3 2s are 6. Minus 6 plus 2 is minus 4. This is 0, this is 0, and this is again minus 4. Clearly you can see that when we divide this whole number, multiply with this and this, then the result would be identity matrix. Okay, so I'm writing identity because we already know that identity matrix is this. So when we multiply this with this and this, that would appear identity matrix. Now I'm doing the right hand side. What is the right hand side? B inverse into B. Okay, B inverse into B. So directly I knew that this is B inverse. Okay, 1 divided by minus 4, or this, minus 2 minus 2 1 3, if I am not wrong. And what about B? 3 minus 1, 2 minus 2. This is the B matrix. Okay, now multiply minus plus minus 2 3s are 6 plus 2, then minus minus plus 2 plus minus minus 2, minus plus minus 2 3s are 6 plus 3 2s are 6. Minus into minus is positive, put 2 plus minus minus 3 2s are 6. This is minus 4, this is 0, this is 0, and this is again minus 4. So next step, multiplying minus 1 by 4 with the all entries of this matrix. Minus minus plus 4 1 0, minus minus plus, then again 1. This is equal to identity matrix. So we have proved the result that B into B inverse is equal to identity, and B inverse into B is also equal to identity. Okay, now moving towards our next question, question number 5. What is it saying? Determine whether the given matrices are multiplicative inverses of each other or not. Okay, part number 1. 3 5 4 7 and 7 minus 5 minus 4 3. We are going to determine that whether these two matrices are multiplicative inverse of each other or not. How can we be able to do its solution? We will multiply the both of the matrices, and if the result is identity matrix, then it would be clear that both of the matrices are multiplicative inverse of each other. If the result is not identity matrix, then these are not the multiplicative inverses of each other. So let's start. 3 is going to be multiplied with 7, with now I'm going to do it. 3 into 7, 7 3s are 21, plus minus minus, 5 4s are 20, plus minus again minus, and 5 3s are 15, plus 5 3s are 15 again. 4 7s are 28, minus 4 7s are 28 again, plus minus minus, 4 5s are 20, and plus 7 3s are 21. 21 minus 20 is 1. They are the same entries and their signs are opposite, so we are going to write 0. It will also make 0 and it will make 1. So you can see its identity matrix. So both of the matrices are multiplicative inverses of each other. Now part number 2. 1 2 2 3. This one, and the second one is minus 3 2 2 minus 1. Yeah. Now to multiply them, plus minus is minus, 3 1s are 3, then plus 2 2s are 4. Then again you can see that 1 into 2 is 2, plus minus minus, 2 into 1 is 2, plus minus minus, 3 2s are 6, plus 3 2s are 6, 2 into 2 is 4, plus minus minus, 3 1s are 3, 4 minus 3 is 1, 2 minus 2 is 0, This is also 0 and 4 minus 3 is again 1. So you can clearly see that this is equal to identity matrix. So these are also the multiplicative inverses of each other. Now we are going to do the question number 6, the last one. If A, B and C are given, then verify that AB inverse is equal to B inverse A inverse. Let's verify. AB whole inverse is equal to B inverse A inverse. Left hand side, A into B. What is the matrix A? 4, 0, minus 1, 2. And what is the matrix B? Minus 4, minus 2, 1, minus 1. Plus minus minus, 4 fours are 16, plus 0. Plus minus minus, 4 twos are 8, plus 0. Minus minus plus 4, plus 2. Minus minus plus 2, minus 2. This is what we have done. Minus 16, minus 8. 4 plus 2 is 6. 2 minus 2 is 0. This is the AB. Okay. Now AB inverse. Take adjoint of this matrix. 0 is here, 16 minus 16 is here. And change the sign. It would be positive and 6 will become negative. Okay. Now divide it by the determinant. Minus 16 into 0 is 0. Then negative sign of the formula. 8 6 are 54. I think 8 6 are 48. Sorry. Minus minus plus 1 by 48. 0 8 minus 6 and minus 16. This is AB inverse. Now we are going to do the right hand side. B inverse would be equal to, what is the matrix B? Matrix B is minus 4 minus 2 minus 4 minus 2 1 minus 1. This is the matrix B. Okay. So when I take the adjoint, minus 1 minus 4 2 and minus 1 divided by minus minus plus 4 and then minus of the formula, and minus 2 into 1 is minus 2. So we can see that B inverse is equal to 4 minus minus plus 2. 4 plus 2 is 6. Minus 1 2 minus 1 minus 4 whole divided by 6. This is B inverse. Now A inverse. The matrix A was that. Now 4 and 2 would change its places. 2 and 4. And the sign of these two entries would be changed. 0 is always neutral. We cannot write minus 0. And now multiply these two. 4 2s are 8. Minus 1 into 0 is 0. So no need of writing it. This is B inverse matrix and this is A inverse matrix. Now we are going to do B inverse, A inverse. It was 1 by 6, minus 1, 2, minus 1, minus 4. And what about A inverse? it was 2 by 8, 0, 1 by 8, 4 by 8. Or I can take common, 1 by 8 can be taken common. It would become 6 into 8, 1 by 48. Minus 1, 2, minus 1, minus 4, 2, 0, 1, 4. 1 by 48. Minus 1 into 2 is minus 2 plus 2. Then minus 1 into 0 is 0 and 4 2s are 8. Minus 1 into 2 is 2 and minus 1 into 2 is minus 2 and minus 4 into 1 is minus 4. So minus 2 and minus 4 will become minus 6. And then minus 1 into 0 is 0 and minus 4 4s are 16. So you can clearly see that left hand side is equal to right hand side. Now the last part. dA inverse should be equal to A inverse D inverse. Take the left hand side. First I am going to multiply D with A. What is the matrix D? 3 1 minus 2 2. This is the matrix D. Now matrix A is 4 0 minus 1 2. 4 0 minus 1 2. 3 4s are 12 plus minus minus 1. 3 into 0 is 0. 2 1s are 2. Minus plus minus 4 2s are 8. Plus minus minus 2 1s are 2. Then this would be 0 and 2 2s are 4. 12 minus 1 is 11. 2 minus 8 and minus 2 is minus 10, 4. This is the matrix DA. Now we are going to take the inverse of matrix DA. All we need is to get the matrix of this. Adjoint of A. Change the places of diagonal entries. And change the sign of other entries. Divided by 4 into 11, 44. Minus of the formula and minus this will become positive. 10 2s are 20. 4 minus 2, 10, 11. You can write it here. 40 plus 20, 60, 64. Okay. And now I'm going to do is right hand side. A inverse. A inverse is here. 2014 divided by 8. Or you can write 1 by 8, 2014. This is A inverse. Now D inverse. This is the matrix D. Then its adjoint. 3 and 2 will change the places. 2, 3. These will change the sign. Minus 1 and 2. The whole divided by determinant. 3 2s are 6. Minus 2. 6 माइनस माइनस मतलब प्लस 1/8. 2 minus 1, 2, 3. This is D inverse. Now A inverse into D inverse. 1/8 into 1/8. 2014. 2 minus 1, 2, 3. 1/64. 2 2s are 4. Then this is 0. Minus 2. 1 2s are 2. Plus 4 2s are 8. That would be 10. Minus 1 and 4 3s are 12. 12 minus 1 is 11. So it is clear that left hand side is equal to right hand side. This is proof that dA whole inverse is equal to A inverse D inverse. For now, we are done with exercise 1.5. Inshallah, in next video, we are going to solve the initials of exercise 1.6 from page number 24 to page number 28. Up till then, please subscribe the channel for further videos and critically comment if you have any problems regarding my videos. जहाँ रहें खुश रहें शादो आबाद रहें हमें दुआओं में याद रखें अल्लाह हाफ़िज़.